The way it's been designed. So three layers are there. So one layer is what the outer layer, where you have all these services. So these services are managed and it's been residing in Snowflake. Okay. So where all of these services will be enabled all the time, and it will be collecting information about your data. That is, the metadata information is being collected, and as well as it will provide you those information to the users. So whenever you require, right? So something like, for example, if you want to create some users, so you want to do some access control, so that can be done by this particular layer. And if you want to do some sharing, data sharing, and if you want to implement the security, so all these optimization, so everything else other than data related, so this layer will provide you these services which are all related with metadata. Okay, so that is what this layer is about. The next layer is actual compute. So your SQL data engine resides here. So where you will be able to run a query, execute a query. So any type of query you want to execute, so you want to load data or you want to put a select statement, so where you can do some analysis over there. So everything else can be done over here. Okay, so that is what the next layer, we call it as compute layer. The third one is the storage layer, where all your data is being residing, right? So whatever data you are loading, so all those data will be residing out here. So that is what the third layer, storage layer, is about. So Snowflake, the entire Snowflake is made up of these three layers. Okay. So that's the way it's been designed. So let us just check it here. Scaling and elasticity. What do I mean by scaling? Scaling is, we know that. So we need to, sometimes we need to increase the capacity of the system. So whenever you want higher capacity system is to be implemented. So when you will be having a larger query is going to be executed, or when you want to accommodate more users so that they will be using parallel processing. So that time we need to scale up our compute systems. So that is what scaling is about. So elasticity is whenever you are scaling up, so that will be made like it can accommodate more users, or it can be capable of executing a very large amount of data. Then after that, your requirement is over and you want to go back to your previous state. So that is what the elasticity is about, right? So you can expand it and you can just shrink it at any point of time. Right? Both your storage, compute, so both of them can be expanded at any point of time and it can be shrunk at any point of time independently. Right? So that is what the scaling and elasticity is about. What are the services you are having here? Right? So the first layer we talked about what services you are having here. So the services are the brain of the Snowflake architecture, because whenever you are accessing a Snowflake account, your account, so you are going into these services only. So anything you reach through these services only. So whether you want to invoke your compute, whether you want to reach your storage to get some data from that, everything through these services only we can go inside, right? So authenticate user sessions. So when you start working on Snowflake, it means that you are working under one session. So when you can create multiple user sessions, right? So these user sessions are authenticated initially by these services, and it can provide management of your service and data. Then it can enforce some security functions. So whenever you are working on data, so how the data has to be encrypted, or how the data can be transferred with secure transferring, and how the data can be accessed. So everything else, all these functions are enforced here only. And the query compilation and optimization. So whenever you are executing a query, so where this query has to be taken, how the cache management has to be done, and how much amount of memory to be used, right? So all of them are being has to be finalized here itself, right? So that is what they call this as a brain of Snowflake architecture. So then coordinate to all the transactions, whatever transactions you are carrying over here. So in the Snowflake, so everything get coordinated here itself, right? Then it is used to construct the status compute resources, which runs across multiple availability zones. So what do you mean by availability zone? So if you are familiar with clouds, you will be knowing about. So whenever you are storing data, the data is being stored in one location normally, right? But in the background, it is available in other zones also, so that you will be having a seamless connection all the time, right? So the end user, if one location, that means if you are loading it in one location, actually it will be loaded into three availability zones. So if any one of the zone is not available for some reasons, the connectivity you have lost for one zone, immediately without any delay for the very small milliseconds of time will be there. It will be connected with another availability zone immediately, right? So that is the way it works. So that will be managed by these services, right? So the security and encryption, key management, so everything else, apart from storage and the execution of query, all the other services will be available here. Okay, so I hope you understand this. The layer is compute. Yeah, next layer is compute. So where you will be executing, just it is comparable to your CPU, right? So where you have the CPU along with some RAM. So these two combinedly together forms this layer, right? So query processing takes place here. So whenever you are executing a query, so for any purpose, so you want to load data, you want to do some select statements, or whatever. Only two of these, if you are going to load data or you want to extract some data. So both of them can take place here. So it can be performed with multiple clusters also, right? So you can create some compute system. Here we call this as virtual warehouses, right? Or simply warehouse. So don't confuse with the data warehouse and this warehouse. So this warehouse means it is a computer. Okay, you can just keep it as a computer. So this virtual warehouse, Snowflake call it as virtual warehouse. So these are all formed with multiple clusters also. So you can have a cluster of computers. So I'll explain them later on in a more detailed manner. Okay. So it is only the minimum data required from storage layer to satisfy. So you can analyze your query, which is based on the services will be passing on the designing of the query execution, right? So you will be having an execution plan. So that will be made by the services, and it can get only the data which is required for your query. And it is possible to cache the query locally. So the results of the query can be cached locally, right? So they will be smartly finding out so what data available in your what data available in the result set, and how much of data can be cached here, and how much of data can be reused. So that way they can just create this cache memory. The cache memory is already there. They will create a plan for storing the data, and it will be stored under the cache memory. Right? Same manner, you can operate multiple virtual warehouses simultaneously. So in the same data, because it is these are all independent layers, so what you can do is you can operate multiple virtual warehouses. So one warehouse for loading data into a database, and another warehouse for doing analysis on the same database. Right? So like that, you can split your workload across multiple warehouses. Okay. The last one is storage. So the storage is built on cloud blob storage. So blob storage you will be knowing about. So very large object, right? Binary large object. So where you will be able to store any type of data over there, right? So any type of data you can store. So any diverse data. It can hold tables, it can hold query results also. That diverse data means it's not just tables, it is there. You can load files also, right? So how you can store data in your local system, so like that you can use them to store files, right? Snowflake support files which are all formed in some formats, right? So CSV, JSON is the main formats we have. We have other formats also. We'll be seeing that. Okay. So then it is assured to have the maximum scalability, elasticity, and performance capacity. So whenever you talk about the storage can be scaled at any point of time. Whenever you want to store huge data, you don't need to enable or you don't need to configure anything. Just you just store data, it will be expanded automatically and will occupy. The data can be occupied into the storage, right? Similarly, you can use for data warehousing and analytics, and this is engineered to scale completely independent of the compute resources. So you don't need to worry about how much compute resource can handle, right? So that is a different layer. You may have a compute resource which is very small to handle a huge amount of data. That doesn't matter about when you are storing data, right? Storing data and the compute, both of them are independent. They can work independently, right? So the data is stored in micro partitions. So normally in a database, you know that there are partitions in the database. So each of the table can be stored in multiple partitions. To have a better performance, we will be using partitions, right? Here also we use partitions. These are called as micro partitions because the size is comparatively small. So maximum of 16 MB of compressed data, maximum of 500 MB of uncompressed data. So that will be stored in one single partition. Okay. So whenever you are loading data into that one, so you will be having multiple partitions will be created for each table, right? So the partitions can range from 1 to millions of partitions inside, right? So we don't have limitations about that. So I'll be explaining you about how these partitions are created and in what way the Snowflake is storing data so that it can be getting the maximum advantage of this on performance wise, right? So that we will be explaining later on. So just simply you understand that. So data is loaded into partitions only, right? Automatically it will be splitted and it will be loaded into partitions. Metadata is extracted. Whenever you are loading, the metadata also is extracted and it will be kept separately so that without disturbing your actual data, metadata can be accessed. Something like, for example, you want to have a total number of records available in a table. So every time it doesn't need to count the records. So the total number of records will be stored separately. So without going and without reaching the actual data, you can just check what is the total amount of records available in each table, right? Something like that. So the micro partitions are columnar, compressed, and fully encrypted. So these are all columnar storage. So the data is not stored on row wise. Data is stored on column wise. Okay. So that means whenever you are using a data, so the data is being whenever it is stored, you will be loading the data on row wise only. Normally we will be loading data row wise. Every row will be loaded one by one, but it will able to split the data on column wise, and every column wise it will be storing the data, okay, internally. So we will see that. So how the data is being stored and all. Waiting it off. We will quickly go through this. So how the architecture is formed and all. Whenever we are going for the performance tuning, so how the data is being stored in detail, you will see that. Okay. AWS, how they are using, right? Vijay?
Yes, Murli.
AWS is using a service called S3. You have heard about it. So the S3 is the here. Okay. Whenever you are creating Snowflake under AWS, the S3 service will be used for storing data. And the EC2, you have heard about EC2, right?
EC2, no, I haven't.
Okay, no problem. So there is a service called EC2, so where you can create virtual systems, virtual computers. Okay, that service is used to compute, right? So just to have an idea, we will be talking more detail later. Okay. So what are the benefits about Snowflake when we are talking about these things? So independent storage and compute layer is the one of the benefits here. So that is why we'll be having a great performance, parallel computing, shared and both not shared. So both hybrid kind of thing. So all are possible because of this independent storage and compute layers. Okay. Instantly scalable. Both of them can be instantly scalable independently without disturbing another one. So activity in one warehouse will not affect another warehouse activity, right? So for example, you are doing some load, data loading is happening. So what happens when you are loading data normally in some other databases, so where you are using in on-premises, so that may affect the other users also. So whenever they are executing a query, which a complex query where it involves more kind of aggregation, grouping, sorting, everything is happening together. So that may affect the performance of a query, right? So when a heavy loading is happening. But here it is not the case. So when one warehouse is being assigned for loading data, another warehouse you assign for executing some queries. So both of them can work independently and it won't affect the performance at any point of time, right? Because the resources what you are using for one warehouse is not been shared with another warehouse. It is all both are independent. So we will be having a seamless way of working, right? That's the thing. So multi-clustering for unlimited concurrency. So what do you mean by multi-clustering? So each of these warehouses can have multiple clusters, right? You can have one single cluster. Cluster you can imagine as a core computer, right? So you have a quad core, right? Like that you have octa core, like that you are having processes, right? So you can just imagine something like that. So where you will be having multiple clusters together. So these clusters are used for parallel processing, right? So for example, if you are having some 5 users, for example, I'm telling it is not the real way of measuring the performance. I'm just telling you an example. So when you are having 5 users, maybe one cluster is enough. When you have 10 users, you need to have 2 or 3 clusters, something like that. So when you are adding more and more clusters, what happens? You can handle parallel processing more easily, right? So that is what the capability of this multi-clustering. Then asset integrity across all values. So asset integrity where we will be available for any type of data. Nowadays, they are almost all are having this atomicity, consistency, right? Integrity and so that is the asset integrity for database over there. So that will be always been implemented here across all the values. So they will be working under this asset integrity standard, right? Then transaction commits are immediately visible. So you can set transaction for auto commit, or you can create your own transaction and you can commit at your convenient time. So that means that manual commit also can happen. So any type of commit whenever you are doing. So if you are loading data and if you are committing it using one warehouse and I am doing a select statement from another warehouse, so I can see the data immediately once you have committed, right? So you don't need to do any kind of additional refresh or reconnecting. That is not required here, right? So even both of us are working on the same database and you load data and I'm just extracting data. That means I'm doing some select statement or something like. So both of us will be working independently, but any commit you are doing that will be visible for other variables also if it is working in the same database. Okay. So that is what the benefits of the architecture. Similarly, the performance and throughput wise, the compute resources can scale linearly. So linear scaling can be done by for the compute resources. That is for your virtual variables. So what happens? It delivers the query results in a fraction of time when it is compared to legacy or on-premise systems. So all of this, that means that we can scale your warehouse. Data is being stored on columnar storage and it is stored on micro partitions. All of them results in a very fast manner of processing queries. Right? So I will show you later on about the comparisons many people have done by executing the same amount of a query. And that is the data. So where they can be using the on-premises database like Oracle or something, and then they execute the same amount of data in Snowflake, and they will be comparing the time. So we will be surprising about the results. So the Snowflake is performing in a far better manner, right? So the virtual warehouse size also can be set initially as one size, and due course it can be increased, right? On the runtime it can be increased without affecting any type of query. You don't need to stop the warehouse for resizing it, right? So normally, if you want to add more RAM into your server, initially 32 MB is available. For example, 32 MB. I want to increase to 64 MB. So what you have to do, you have to stop the system and then you need to add more RAM. Then you have to restart it, right? So what happens on that time, you will be having a small amount of delay for your users, or you will be having a small downtime, right? So that will never happen here in this cloud. What happens when you want to increase the size of your warehouse? You can just increase it by using a command. So the users who are all connected with this warehouse, they don't feel like there is a time delay or something like that, right? So it can be resized while you are running itself. Then you pay only for what you use. So we have an option of passing and resuming the warehouse automatically. When there is no query is being executed, the warehouse will be passed. It will be stopped, right? It is passed. So what happens when you are passing it, the charges will not be there. So for example, we execute a query which the query takes 5 seconds. So I will pay only for 5 seconds of usage. I don't need to pay for what I am not using for, right? So that is the way it works, and it will be more helpful for the end users to have running the queries in a more economical way than executing in an on-premises. So these are all about the performance and throughput that is available by the benefits of the architecture. Similarly, storage. Storage is also inexpensive and it can scale virtually indefinite. Indefinite storage. When you are talking about the storage, it happens like you can store petabytes of data, right? So whatever available on our own premises. So whenever the disk is being full, we have to increase the disk at any point of time. Again, you have to stop your system and increase the disk amount. So which is not required here. So you can just store data whatever you want, automatically it will get increased. You don't need to do any settings for accommodating a huge amount of data, right? Again, another thing is the data is stored in a compressed manner. So compression can happen like a zip files, right? So you are storing the data, by default it will be compressed and it will be stored. So what happens, your storage will be compressed at least 3 times or 4 times, right? Depends upon the data and other factors. So the compression can happen either 3 or 4 times lesser. So for example, if you are storing 300 GB of data, actual storage takes place here as 100 GB of data only, right? For example. So what happens? You will be paying only for what amount it is occupying, not for the actual data you are holding. Okay. So that also will reduce the cost of storage. Then the storage of semi-structured data also happens in the same manner, so that you won't find difference when you are querying them with a very small change, very small change of the query. You are able to access the semi-structured data also in the same manner how you are accessing the structured data, right? Something like a select statement will be used, same select statement will be used for querying your JSON, Parquet, and other service also. Okay, so that is what querying and loading. Schemas are dynamics. So in many NoSQL databases, you will be seeing that. So you will be having a dynamic schema, right? So in a normal databases, normal relational database, you have to define the schema before loading data, right? So once you have loaded data, so it is really difficult for changing the schema. So here you have a dynamic schema available, and it can be automatically detected while loading, right? So it will be leading to efficient query execution using the natural extensions of SQL. So Snowflake follows ANSI standard, right? So you'll be knowing about ANSI standard, so which they are formed on 80s, and they are keep on adding more and more new features which are all available on SQL. So the ANSI standard is being followed. So it is easily able to migrate any of the data environments you are having with any on-premises. So, for example, SQL Server, Oracle, Teradata, they are all following ANSI standard. So what happens, you can easily migrate them, the code and everything else here into Snowflake. So with the minimal amount of modifications. Okay. So that is what storage and support. And sharing is important part of data warehouse, because once you have loaded all the data and given all these structure properly, and you have designed your environment, everything else is happening. What for? You need to share data with others, right? Many times the sharing normally in on-premises, it can happen for sharing your entire data, and they will be accessing through the same way the other users are accessing, and they have to go through all these kind of stuff. That means that the workflow and all will be the same. But here, what happens? Snowflake share the data into a separate account, and those people can use their own resources for accessing the data, right? So they will be not using our own warehouse. For example, if you are sharing data with me, I will be using my warehouse for accessing your data, and you will not be charged for any additional access, right? So that is the way the sharing is happening. Okay. Initially, you need to create a share, and you have to add who are all the account users for capable of getting this data, right? So that is done with secure way of sharing. Okay, so because only the Snowflake users are able to access, so they will all comply into this security management, right? And you will be having only read-only copies. So if you are sharing your data, I am not authorized to change any of your data at your place. But I can make a copy and I can share it. I can modify with my limit, right? So that is the way of doing it, and the sharing data will not incur any charges. So because the data is stored only once, access only is given to other users, so there is no additional charges over there. Okay. If you don't have account, for example, you have an account with Snowflake and I don't have an account, but still you want to share with me, because that happens many times. So you are some of your vendors or some of your clients, so they don't want to create an account with Snowflake. But still they want to view your data, which is available on Snowflake, right? So that time what you can do, you can create your own account and you can share that account with them. That is called reader accounts. Okay. So you can share them. We will be seeing it. We are going to do the sharing also. Right. So everything, whatever we are seeing here, we are going to do them practically. Right. So that time we will see that. So the data can be shared with other account users as well as normal public people also. Right. So what you require is you need to just share. You need to enable the sharing. That's it. And you have to include to whom you want to share. That's all. So no complexities of email or STP. You need to make another copy of them. You need to restrict those people for accessing your data. And all. So not required for that. Okay. Easy way of sharing using normal SQL queries. So you can share them over there, right? Like how you are granting access to other users. So like that you can grant. So the next thing is about the availability and security. So high availability with Snowflake scale-out architecture. So what do you mean by availability? So it will be available all the time, even if you are meeting with any kind of failure, right? Connection failure or any kind of disaster if it happens. So Snowflake provides you availability over here, right? Similarly, it can provide you more security also. Two-factor authentication, federation authentication, single sign-on access can be given, login, right? So these are all by default Snowflake provides, right? So it can limit access by policies. So it can create policies. So you can allow only a list of users. That means they are all identified by their IP addresses. Or you can provide some roles for them, and based on the role they can access. And you can give an additional authentication also. You can use a mobile app and the mobile app will generate some security code. So only after providing the code you will be able to do it. So two-way authentication, right? So like that, they are providing you high availability as well as more kind of security. Data is being encrypted all the time. When it is stored or when it is transferred, both the time the data is being encrypted, right? You can opt for automatic encryption or you can go for your own encryption. So you have to provide your own key and what method of encryption you want to do. You have to specify into Snowflake. So it will be following your own encryption methods, right? So that is available here in Snowflake. So security-wise and compliance-wise, so in US and some other European countries, you know that so the data has to be compliant for multiple standards they are following already, right? So SOC type of reports for auditing purpose, for accountability, so for health related funds and all, HIPAA and everything, right? So the Snowflake is compliant for almost all popular level of standards, right? So this is available over there. So you can use for any of these reporting purpose. Okay. So that's a kind of a small see this in architecture. User interface, so you can access them using web UI or any other drivers Snowflake is providing. Cloud services only you will be reaching initially. So the cloud service query management you are talking about. So whenever you execute a query, it goes to that and it will be executing them using the virtual warehouses, right? And then the virtual warehouse finally it will be reaching your storage. Picture here, little more detail about how the data is being stored here. So you can see the S3 storage, it is stored on multiple micropartitions. And inside your virtual warehouse, you can see that they are all available on multiple clusters inside. So the warehouses are classified by the size, those extra large, small. So Snowflake calls them as t-shirt sizes. So how you are having a t-shirt size? It starts from small and it can go up to 4XL, right? So that is what. So small means we have 8 nodes inside. So and the 4XL means 1024 XL. So each of them contains 8, right? One node contains 8 core inside. Okay, so that is the way it is being formed. So whenever you want to increase more and more core, so you increase the size, right? Increase the size means you can provide a small command, increase size, so that's it. So it will be increasing the size of it. Okay. Then the storage happens here. You can see that each of the storage, Snowflake data, sales, marketing, like that, they are having some storage over there. So separate databases you can create. Database is the core storage. Inside database, you will be able to store what are the other objects you are having. So for example, you can have a table, you can have a view, then we have store procedures, right? Everything else, like any database, you can store all kind of stuff together. So using the DML and DDL, the cloud services are responsible for providing the queries. So whichever query is being executed by the end user, it has to go through the cloud services. So then about micro partitioning and clustering, this data is being stored here. What is about the high availability, right? So we talk about this little later on. Okay. So I'll just want to run through some of the important basic hands-on here. Then we will go to this one. Is that okay, Ajay?
Fine now. Okay.
So let me open my system here. So whenever are you having break in my voice?
A little disturbance is there, Murli. Actually, it's not complete.
Okay, no, because my connection is switching over. That's why you can tell me any time because we all forced to work on home now. So I'm on the here. I'm residing in Chennai actually. So the connectivity and all, sometimes it might not be good. So I have 3 internet connectivity connections here with me. Each of them, whenever if one of them is not good. Okay, so you don't need to hesitate for telling it. So you can tell me at the end of time if it is not good. Okay, because we are the one only we are doing. We don't have any group of people here, right? So if not comfortable, that means that 100% it is not comfortable.
Okay, got it.
If you are working under a group of people, 4 or 5 people will be there normally. So that time it is okay. If any one person is having any kind of issues, so that may depend on him only. But here it is. So please tell me. I'm open to accept anything else here, right? So your comfort is important. Because I have my window here, so sometimes strong wind is coming here. I'm staying opposite to your lake, so sometimes the wind might be higher. So some disturbances might be there. So just tell me about so that I can change directions, something like that. I can do something over here.
Yeah, sure. Yeah.
So how about this now? Is it okay or you
It's
still?
okay. Yeah, it's okay.
It's okay now. Okay. Fine. So let me open our. because you want the break on next 3 days, right? Is that Vijay?
Attend only.
You need a break for another 3 days, right?
No, okay. For you, it will be from Tuesday to Friday. So tomorrow I can attend.
Okay, fine. Fine. Talking about your mates, right?
Right.
Okay. So tomorrow we also will connect. Because I thought of when you are taking some break here, that means a weekend. So I can give you some little exercises so that you can get out. That's what I thought about.
Oh, okay.
So let me explain about this now here. That you see this, when opening you will be seeing this one, and you will be having a empty worksheet. Normally you don't have, so you'll be having something like this. So your account also look very similar to this one only, right? Fine. Now we'll start with some basic things here, right? So first thing, you should have a database, right? So for what you should have a database.
Right.
So when you want to create a database, this is about accessing the metadata layer only. When you create a database, you are not going to store data or you are not going to access any data from the database, right? Just you create a database means you allocate a location and you name it. That is what actually it means technically, right? So to create a database, you don't require a warehouse. Okay, you don't require a warehouse. So without a warehouse, you can create databases, you can create tables, and everything else can be done. So these are all metadata operations, right? Fine. Then while you are loading data, definitely we need a warehouse. Similarly, when you want to when you want to access the data, when you want to extract some data from that, definitely you need a warehouse, right? Fine.
Right.
I told you warehouses, databases. These are the two objects. Warehouses means you think warehouse is a computer. Okay. Storage means a database means it is a storage. Right. So physically you think of warehouse means it is the CPU and the database means it is the hard disk. Right. So something like that you in your mind. Only two objects, major objects, right? Fine. So initially, when you see your account, you have this is what the context of your session. Okay. Once you open your sheet, one session is being opened. So you are seeing the context of the session. You will be having a role. By default, you will be given a role called the sysadmin. Okay, I will explain the roles later on. You will be given a role called sysadmin. And you have what you call value is called compute WH. Okay, so these are all by default it will be created, and you don't have any database and schema. Normally, it is not selected here, right? So if you want to work on any database, initially you will be having some databases. 3 databases you will be seeing. New test is the one what I have created. Okay, so ignore that one. Other than that, DemoDB, VirtualDB, these 2 databases they have created for just for demo purpose. They are all empty databases. They don't have anything inside. But another database you are seeing here, Snowflake sample data, it contains a huge amount of data. Okay, TBs of data it contains. But these are all not residing in your account. Okay, these are all shared by Snowflake. So, okay, I told you now, sharing means when you are sharing your data to me, I will not be having the data on my premises. Okay, it will be under, I'm sorry, in my account. It will be under your account only. You just allow me to see the data. That's what it means, right? So Snowflake is having its data over there. So it will be having huge amount of data which you will not be charged for that. Okay, they are sharing the data for practicing for demo purpose and all. Okay, so that is the thing. So I'm just doing inside the data here. You see that these are all schemas available. Okay, these are all schemas. Multiple schemas are available. One of the schema here, you see, it is information schema. Information schema is a default schema which will be available on every database. Whenever you create a database, two schemas will be created initially, right? So I'll just go to the new test schema database here. You see, two schemas are created by default. One is called as public, which you can use. Another is called as information schema, which you cannot use for storing data, right? The information schema is something like a system schema, which is being managed by the system itself, right? So you can use the information schema to know about your database, that particular database, right? So all the information about the database, how many tables are there, how many views are there, who are the users can access this, something like that. So all those information you can get it from there, right? We'll see them later on. Everything else we will be seeing in detail later on. Okay.
Okay.
So the public will be there initially. So inside the public will be empty. Initially it will be empty. You need to create some tables, and you can create views and all, right? Everything else you can create it over there. That is the first thing. Then when you talk about this Snowflake sample data, you have information schema, and they have several other schemas they have created. The standard of TPC, TPCBS. So these are all some standard transactional process data has been available. Okay. So these are all standard data available. It is not just Snowflake data. Standard data which is available globally. So there Snowflake is providing data. Okay. These are all defining the size of the schema, everything else. So again, so the bigger size is this one. Okay, it will be having a huge number of data. You can see that. I just go into this schema. You see that a lot of tables are available. So one table you can see that this one line item is one of the table. You see that the size it provides you a mouse over. If you are mouse overing it, it gives you a kind of thing. In the black window, it's opening. In that one, you can see the number of rows there, right? So the number of rows goes to billions. 59 billion records are there, nearly 60 billion records are available. So that much big data is being stored here already. You can make use of them at any time of right. 1.7 TB is the compressed size. Okay, compressed of the data. You go to the lowest one. This is the lowest one we have. So here you see that we have the same line item. If you go, it is 157 MB. That is the lowest it can store. Similarly, you can go to this other one also. So the line item is 1.5 MB only. This is the lowest one. Okay, this is the lowest one. So you can apply the queries, normal queries, if you are familiar with SQL queries. I know that you have very good expertise in queries. I'm just telling for normal personality. Just say, for example, select star from execute it will fail because I have not chosen which database I am going to work with and which schema I am going to work with. Right? So what you can do is, for executing a query, you have to select which schema and which database you have to work. Otherwise, what you can do, you can go to the customer table and you can click place name in SQL, so it will be placed here. So you have to end up the semicolon and you can run this. You can use the run or command control plus return. That also you can do. Okay.
Hello. Hello.
Yeah. Tell me this.
Is the double quote syntax for this, like for everything, like a
no. Double quote is to maintain the spaces, uppercase, lowercase.
Okay.
Not required. But if you want spaces, if you want to include space in between, in SQL Server we use that, right?
I mean, yeah, in SQL Server we use
Square brackets.
closed brackets, open and closed.
Yeah, square brackets we use, box bracket we use,
Okay.
right? We use double quotes. Okay. So when I execute it, so this will be giving you data, whatever data here. It's so simple. So it's what I have to do. Even now, you have not selected any schema or database. You see here in this area, I'm highlighting the area, you can see that. So here, no database or schema selected. You have two ways of selecting a schema and a database. So what you have to do is you go inside, you have to select what database you want and what schema you want. You can select that. And just run a command. This schema, I can go to this schema here and I can again paste it. Use schema. Now you will be having a message called statement executed successfully, and you will see the context now. The context is fixed for this particular schema. Now, if you execute any type of query, that query will be executed under this schema only. It will not go away from the schema. For example, I put the same thing, select start from customer.
Okay. Oh, is the same? Is the same like use the database name, right? Is the same like that?
Yeah, that's right. So we have used database also. So if I want to use the other database, new test. So for databases alone, you don't need to give the keyword database.
Okay.
Both are same.
Both are
using data or with the database, both are same. It won't.
Okay.
Yeah.
Got it.
But for example, the schema name is, for example, I have a schema called public, right? So if I put use public, use schema public. So that has to be executed along with schema. Right? If I give use public means that will recognize this as a database. So you cannot give it like this. So if I
got it.
It's not exist. Right? It will be going on. So that's a basic thing about this. So what we will do today is you know that the warehouses are there. So just I go through this one, you see that warehouses having only one warehouse, right? So just take a look on this warehouse. We will be creating warehouses later. Okay. So tomorrow we will create some warehouse and that. So you can just go through the warehouse and you see the what all the available query execution which happened here. Right. So you can see that what all the queries executed, how much time it is running. So that is how you'll be seeing about the warehouse. And you just choose the warehouse, you can go for configure. So configure will show you how it is made up of, right? How it is made up of. So like that it is giving you all the information about, right? Similarly, you go to database. So in the database only, you will be having all the other things. So you go to the Snowflake sample data, and you will be seeing multiple tables together. So these are all tables, right? So go inside the views. So if there is any view, the views will be shown here. Similarly, schemas. Three are most common for any database, right? Schema, view, and table are most common. Other than that, we have other objects you are seeing: stages, file format, sequence types. So I will be explaining you later on. I'll explain about everything. I've shared the content with you just to take a look on that course content. So we will be covering more extensively about everything.
And will you be sharing any material?
Yeah, I will share some material which can be used for reference purpose. But this material can have is on online only Snowflake documents. Okay.
Okay.
I'm showing you now. I will share a material which I have summarized all the information I am giving to you. Okay. Because if I have to read a material that will go for nearly 2,000 pages or something, it's easily we cannot do it. So
Right.
I've given you, I summarize all the topics together, which are essential, just to read and have an idea, which that will be enough for you to work it on in some early stages. But when you are start working on Snowflake more and more, you cannot work with that alone. Okay. So you have to go with document only. When you want to prepare for certification, when you are working on Snowflake in some projects, everything else, this is the place you have to come. Okay. I'll explain you later on about how to use this more smartly, how you can use this tool.
Yeah.
I will be giving you some materials. I have some other kind of hands-on, step-by-step information I will be giving you. Okay. Information about how to do those exercises and all, right? So all I have framed it. I'll be sharing it with you in another day. I will be sharing it with you.
Yeah, sure.
I'll show you that. So I have a lot of materials with me for Snowflake. You see that these are the PDFs available, right? So I have made them up. Then if you talk about the materials, shareable materials, so these are on each day what should be shared and how it has to be done. So this is for the corporate people. So day one means I will be taking 6 hours every day.
Oh, okay.
Okay. 6 hours training. So 6 hours, 6 into 5 days, 30 hours total training hours for corporate people. Okay. So for them, I every day one by one. Then you talk about the worksheet. So each worksheet is containing a set of queries for some particular purpose. For example, if you want to know about this time travel, so I have explained the time travel here in the set of queries. You see that how it has to be executed, what components inside. Like this, I will be having nearly more than 20. You can see that items are there. More than 20, 25 items will be there. So everything I will share with you.
Yeah, sure.
All of them I will share with you one by one. A lot of time, Vijay, don't worry about it. Right? We have 30 hours of time for it, definitely. So I will be sharing with you one by one. Because initial stage you might not require them. So once you understand how it is working, then you will be able to work it out easily. 2 days it will take for understanding things together. After that, you can start working on your own side because you have good experience here. You don't need every time you need a help from me. But I'm here to help you at any time. Okay.
Okay, sure.
We'll go to it together. Yes. Is there anything else about this today?
No, nothing. I'll just go through this few things.
If you have,
Your voice is breaking.
yeah, tell me.